Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. I am dealing with the subject Network Analysis and Control System. I have already done the Module 1 and Module 2 Network Analysis topics. Videos are already uploaded in my channel. If you want the videos, you can check out in my YouTube channel. In the control systems, I have already started with the first video which is uploaded already. Today we are going to see a new topic in the module 3. We have already done the introduction types of control system in the first video. In this video, I am going to deal with the effects of feedback system. What are the effects of the feedback system? Effects of feedback system. One use of feedback is for the purpose of reducing the error between the reference input and the system output. As we discussed, and in the last video, I told that the feedback is used in reducing the error, as the output is going to be given to the input as a feedback, and there is a correction happens, error is found, and again fed into the control system so that the error can be reduced. Feedback also has effects on such system performance characteristics such as stability, bandwidth, overall gain, disturbance, and sensitivity. Okay, it has on such system performance characteristics, there is stability, bandwidth, overall gain, disturbance, and sensitivity. In general, we can state that whenever a closed sequence of cause and effect relationships exist among the variables of a system, feedback is said to exist. When they are what it is told in general, we can state that a close sequence of cause and effect relationship exists among the variable system. Feedback is exists. Cause and effect both are exist in the system. Then it is called where the feedback is said to be exist. Here if you see, this is the reference input. R of S is the reference input. C of S is the output, and this is the summing point, and this is the G of S, and this is H of S. G is the control system, G of S is the control system. G is nothing, H is nothing but the feedback, which is mentioned by H. This is the same system which is represented in the terms of like plus and minus R, plus and minus C, and how exactly internally it is connected with minus and minus, this plus to H. Like how internally it is connected, it is shown. Elaboration of this circuit is the feedback system with one feedback. It is only one feedback loop. The input-output relationship of a single loop control system. The input-output relation for this feedback control system is M is nothing but the transfer function. M is nothing but the transfer function, that is nothing but output by input. C is the output, R is the input. So C by R. C by R is equals to, we are going to take in the way G by 1 plus GH. Here C by R will become G by 1 minus GH. If here it is plus. Here if it is plus, if the feedback is H of S is plus, then you will get 1 minus GH in the denominator. As here it is minus, you are going to get 1 plus GH in the denominator. Okay, keep this in mind. The input-output relationship is nothing but the transfer function, that is M, or we can denote it by T, or sometimes even it is denoted as TF or TF, T, TF and M. We can denote it with any of the things. So transfer function is nothing but the input-output relationship of the control system, which is nothing but the output by input. Output is C, input is R. So C by R is equals to, we get the equation as, if there is some equation, if there is some diagram where blocks are connected in this way, feedback from the output to the input, we can write this input-output relationship as G by 1 plus or minus GH. Here if it is minus, we'll get denominator 1 plus GH. If we have plus here, we get minus in the denominator. Understanding? So this is the feedback system and the block diagram, how it looks, and the transfer function. Now we will see the effects of feedback system. The first effect of feedback on overall gain. The feedback on overall gain. How the feedback affects the overall gain. The feedback affects the gain G of a non-feedback system by a factor of 1 by 1 plus GH. Okay, it is telling that the feedback affects the gain G. The feedback will affect the gain G of a non-feedback system by a factor of 1 by 1 plus GH. If you see, this G is getting affected by 1 by 1 plus GF. 1 by 1 plus GH. So, the system is said to have a negative feedback since a minus sign is assigned to the feedback signal. If minus sign is assigned to the feedback signal, it is called as a negative feedback. If plus, it is a positive feedback. In a practical control system, G and H are functions of frequency. Functions of frequency, the magnitude of 1 plus GH may be greater than 1 in one frequency range but less than 1 in another. See, either these G and H are nothing but what? Are the frequency functions where it can be either greater than 1 in one frequency range or less than 1 in one frequency range. Therefore, it can be greater than 1 or less than 1. Therefore, feedback could increase the system gain in one frequency range but decrease in another. So, the gain can be increased or decreased based on the values, that is 1 plus GH. If it is greater, it increases the based on this greater than 1 or less than 1. The gain can be increased or decreased. This is the effect of gain in the feedback system. Okay. Then effect of feedback on stability. Effect of feedback on stability is a notion that describes whether the system will be able to follow the input command or be able used in general. A system is said to be unstable if its output is out of control. The system is said to be out of control or is unstable, means it is not in the control of our hands or it is not in the control of the inputs, then it is called unstable. If it is can be controlled, then it's called a stable system. If GH is equals to minus 1, the output of the system is infinite for any finite input, and the system is said to be unstable. Understanding? If GH is equals to minus 1, the output of the system is infinite for any finite input and the system is said to be unstable. Therefore, we may state that feedback can cause the system that is originally stable to become unstable. The feedback can make the stable system unstable or unstable system as stable. So, it can be either ways. It can make stable or unstable. In general, GH is equals to minus 1 is not the only condition for unstability. In general, only if GH is equals to minus 1, it is not like it is conditioned for instability. One of the advantages of incorporating feedback is that it can stabilize an unstable system. There is a chance that the feedback can also stabilize an unstable system. What it means is either the feedback can make the system stable, which is unstable, and which is unstable, it can make unstable to stable, stable to unstable by the feedback. It can be made by either, in some cases it can be advantage or it can be disadvantage. Let us assume that the feedback system unstable because GH is equals to minus 1. If introduce another feedback loop through a negative feedback gain of F as shown in figure below. See, GH is equals to minus 1 is unstable. That telling if introduce another feedback loop through negative feedback gain of F, then what happens? How to write this now? Now the input output relationship will become G by 1 plus GH plus GF. Understanding? G by 1 plus GH plus GF. If two loops are under this gain, then what happens? G by, anyway we know 1 plus GH, another loop is also there in this way, feedback loop, so it will become, as it is minus negative loop, we can write as positive GF. Understanding? This is the effect of feedback on stability. Then effect of feedback on external disturbance or noise. Initially we have seen the based on the previously we have seen based on the stability. Now we are going to see effect of feedback on external disturbance or noise. All physical systems are subject to some kinds of extraneous signals or noise during operation. Any physical system has there is some kind of extraneous signals which is not required or a noise during operation. Then examples of these signals are thermal noise voltage in electronic circuits and brush or a commutator noise in electronic motors. There are some noises we get for a system. For example, in auditorium, there is a person who is singing the song. There is time where you won't get the proper signal. That means there is some noise interrupting there. So that is the noise. Maybe it is because of the feedback. It may be because of the feedback. So effect of feedback on the external disturbance or noise. Therefore, in the design of a control system, consideration should be given so that the system is insensitive to noise and disturbances and sensitive to input commands. Here the main thing is, therefore, the design should be in such a way that the system is insensitive to noise. The system should not uh, get active when it is noise. Whenever it is noise, it should not care about noise and you should give the exact output. Means the system is insensitive means it should not consider the noise and disturbances, noise or disturbances, and sensitive to input command. It should be sensitive to input commands. Sensitive to input commands means if there is any change in the input, then it should change the output based on the input commands. It should be sensitive. It should accept the input commands. But the noise or disturbances, it should be insensitive. Sensitive means what? For example, we are sensitive. If we are emotional to some things, means we can, which are required. Which are not required, we should not care about it. In the same way, the system should be insensitive to the noise and disturbance, but it should be sensitive to the input commands, which is very important and required. Okay, in figure, R is denotes the command signal, N is the noise signal. This is the noise signal, this is the reference input or the command signal. In the absence of feedback, H is equals to 0, the output C due to N acting alone. When this is C, H is not there. When H is 0, then what happens? You get as C is equals to G2 into N. C is equals to G2 into N. Okay, C is equals to G2 into N. Then, with the presence of feedback, the system output due to an acting alone is, if there is a presence of feedback, then what is the relationship? C is equals to, what do we get is G2 by 1 plus G1 G2 H into small n. Understanding? This G2n is same for this both, but there is a feedback also present, that is 1 plus G1 G2 H. Okay, G1 G2, as they are in series, we are going to multiply in this control systems. So 1 plus G1 G2 into H, feedback is the H. This is the equation. You need to know these equations, how to write. See, here C, output C is equals to G2 by 1 is there in the formula itself, 1 plus. Why? Because it is minus, you are going to take the plus here, plus G1 G2 multiply into H, the feedback, into N. This G2 into N is when H is 0, and when H is not 0, then you will get this denominator also, the equation. Comparing equation 1 and 2, we can conclude that noise component in the output equation 2 is reduced by a factor 1 plus GH if the latter greater than unity and the system is kept stable. What they are telling is, these two equations, if we compare this 1 plus G1 G2 H, what it is doing is, it is reducing this noise which is present. So the effect of feedback is good. So the feedback will reduce the noise or external disturbance. So feedback as a effect in terms of external disturbance or noise, it is very good. If we apply feedback, so that reducing the noise can happen. So based on this, you can tell that in these two equations, when you are comparing, the feedback will reduce the noise. This is the main thing in the effect of feedback on external disturbance or noise. Effect of feedback on sensitivity. Since all physical elements have properties that change with environment and age, we cannot always consider the parameters of control system to be completely stationary over the entire operating life of system. Since all physical elements have properties that change with environment and change. See, if we compare with humans only, as the age or environment change, we adapt to some things, we change some things. In the same way, physical elements in the control system also there is based on their properties, based on their age and their environment. Age in the sense how many years of usage, environment and age. We cannot always consider those parameters of the components will be completely stationary and work as usual in the lifetime. So there is some change, there is some sensitivity issues. So in general, a good control system should be very insensitive to parameter variations but sensitive to input commands. The same thing which I told before. It should be sensitive to the input commands, but it should be insensitive to any noise or any parameter variations. It should be insensitive to any noise or parameter variations. Consider G to be gain parameter that may vary. The sensitivity of the gain of the overall system, M to be the variation of G, is defined as. So this is the sensitivity formula. Dou M by M by dou G by G. Dou M by M is nothing but percentage change in M. Then dou G by D is the percentage change in G. Percentage change in M. M is nothing but what? We know that input-output relationship, that is transfer function. Percentage change in transfer function, that is M. Percentage change in the gain, that is dou G by G. Where dou M denotes the incremental change in M due to the incremental change in G. See, incremental change in M to the incremental change in D, that is dou G, and this is dou M. So dou M by dou G, if you see this, you can write in the form of dou M by dou G. This G go ups, G up by M, that is equals to, you get 1 by 1 plus GH. Sensitivity formula. How? I'll tell you. See, if you see dou by dou G, M is what? You know that if you consider this, M is what? M is G by 1 plus GH. If you differentiate this, you get as 1 by GH whole square. You get it. After getting 1 by 1 plus GH whole square, what you will do is, you are left with other multiplication, G by M. 1 by 1 plus GH whole square into G by M. M we know again what it is, G by 1 plus GH. So this G get cancelled and this 1 by 1 plus GH will go up. So this 1 plus GH get cancelled. We are remained with 1 by 1 plus GH. I am just telling you how this formula, final formula you got. Just in the place of M, write G by 1 plus GH and differentiate this. After that, multiply with G by M. Again, M is nothing but G by 1 plus GH. Some cancellations will happen. Then you will get 1 by 1 plus GH. In general, the sensitivity of the system, gain of a feedback system to parameter variations depend on where the parameter is located. The sensitivity will be depending on where the parameter is located. So I made such a way that it is easily understandable and the points are less in the sense which are very important points that to be written in exam. I made in that way. So if they ask effects of feedback system, explain the effects of feedback system, then you need to explain this all 4 effects. Understanding? So now we are done with effects of feedback system in this video. With a new topic, I'll upload the next video, that is modeling of mechanical systems elements. So I'm stopping this video here. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.